All right. Example one. The question in purple. How do we find the sum of a finite arithmetic series? So this is an arithmetic series, and we want to find the sum. So we have to take all of the numbers and add them together. So what do you think the sum is? How can we find what are some ways in which we could find the sum of all, emphasis on the word all the numbers in the series? Do you see all the numbers that are in the series? No. What makes you think that there are some numbers here that are not present? The three dots. So that means there are some numbers in this series that aren't present. What are those numbers? Ian? 11, 12, 13, and 14. How did you figure that out? So the common difference is 1. Exactly. So if the common difference is 1, we know that after 10 is 11, 12, 13, 14, 15. When you have a series, they're not going to write every single number. They'll give you some of them, but you have to know what's missing. And how can we find the sum of all of these numbers? Ian? Just add them. So what's the sum? 92? So that's your answer, 92. Now some of you may be thinking, that's kind of easy, but what if instead of 15, it went all the way to like 2040 or something ridiculous like that? Is this the most efficient method to find the sum of all of those numbers? Of course not. So as you already know, you're probably doing a little foreshadowing. This formula on the right is how we're going to figure that out. Maria G, you had a question? That was your question? Yeah. I mean, if you don't mind, like this one is pretty straightforward. You could figure this out without a formula, which we just did. But if the last number is a huge number, the formula is going to be the most efficient way to get the sum of all of the numbers. So we've seen that we can figure this out without a formula. The answer is 92. I'm going to show you how to use the formula over here. S subscript n, this just means the sum of the series. N is the number of terms in the series. So n is the number of terms in the series. How many terms are in the series? Maria? There are not 4. Don't guess. Yusuf? There are 8. Excellent question. Excellent question. So Yusuf, you said 8, and it's 1, 2, 3, 4, 5, 6, 7, 8. Maria G said, what if the number was 2000? How would you know? And this is how you'll know. So the number of terms, you might want to write this down. The number of terms equals the last term minus the first term divided by the common difference. D is the common difference plus 1. Please write that down. You will need to know that in the cases when the number is 1,000, 2,000, or some large number. So Maria G, thank you for asking that question. You are using your brain. Last term minus the first term divided by the common difference plus 1. Did everyone write that down? So as you can see, Yusuf said you could just count it as 8, but if you didn't know the numbers in between, what is the last term? So it's 15. What's the first term? 8. What's the common difference? The common difference is not 2. 1. The common difference is 1. Common difference is 1. So divided by the common difference plus 1. 15 minus 8 is 7. Divided by 1 plus 1. 7 divided by 1 is 7 plus 1, which is 8. That will work every time. So when the number is a big number like 2,000 or 156 last term minus first term divided by the common difference plus 1. What was that? Right here? All right, so we did all of that to figure out the number of terms. So the number of terms is 8. That's very important. When you're using series, you need to know the number of terms you're dealing with. So n equals 8. It's just a part of the formula. You're always going to add 1, no matter what you get here. So when you do the last term minus the first term divided by the common difference, whatever this is, you're always going to add 1 to it. All right. So we did all of that to figure out the number of terms. So n, the number of terms, equals 8. So now we'll take our formula. Wherever we see an n, we replace it with 8 because n equals 8. The number of terms equals 8. So s subscript 8 equals n over 2 times a subscript 1 plus a subscript 8. So far, so good. Does anyone have any questions? Spencer? Yes. Yep. So now, a subscript 1, don't give me the number, but what does a subscript 1 mean? What does it mean? First term. Does that make sense? This means the first term. So the first term is 8. Not to be confused with that 8. This 8 is the number of terms. This 8 is just the first term. So we will replace a subscript 1, which means the first term, with the first term. What does a subscript 8 mean? What is it? The 8th term or the last term. And what's the last term? 15. Please make sure you understand that where this 15 comes from. This 15 is the last term, which is our a subscript 8. A subscript 8 is the last term. So it's 15. Once we have all of our variables replaced with numbers, we could enter this expression in our calculator. 8 over 2 times 8 plus 15. 8 over 2 alpha y equals 8 over 2 times 8 plus 15 equals 92. 92, which is the answer we already knew from before, but this is the way you'll get it when this number is a large number like 2000 or 196 or something like that. This is the formula that will give us the sum of the series. Next example. Or does anyone have any questions about the example we just covered? All right. Next example is on the board. The first thing we need to know is how many terms. How many terms are in the series? How many terms are in the series? 31. There are not 31 terms. Yusuf? 11. Why 11? Let's figure it out. So the number of terms, remember the way we calculate the number of terms, it's the last term minus the first term divided by the common difference plus 1. This is how we figure out how many terms are in the series. The common difference is 3. Again, if in the arithmetic sequence, we're going by 3, so the common difference is 3. So the next number would be 10 plus 13, but we're not going to do that to get to 31. We're just going to use this formula to figure out how many terms there are. So 31 minus 1 over the common difference, which is 3, plus 1. 31 minus 1 is 30 over 3 plus 1. 30 over 3 is 10 plus 1, which is 11. Angelina. The 1 is part of the formula to find the common difference. We're always going to add 1 whenever we do last term divided by first term over the common difference. That's going to give us 10, but 10 is not the total because when we subtract, we don't include the first term that we subtracted, so we always have to add 1 to get the total number of terms. Kelvin. The common difference, you subtract a subscript 2 from a subscript 1. So the common difference is a subscript 2 minus a subscript 1. So it's just 4 minus 1, which is 3. This one is 7 minus 4, which is 3. So the common difference is 3. Kawar.
Didn't you always say the denominator is 1?
Say that again?
Didn't you always say the denominator is 1, like the last question?
No. The plus 1 is always 1. The denominator is always the common difference. So in the last question, the common difference, 9 minus 8 is 1. 10 minus 9 is 1. So in this case, the common difference was 1. So that was the denominator. But in this case, the common difference is 3. So 3 is going to be the denominator. So the denominator is always the common difference, but you always add 1 to whatever you get from this fraction here. Angelina. Yeah. Are you good? All right. So the number of terms is 11. N equals 11. So now we'll just take 11 and replace all of our n's with 11. A subscript 1 means the first term, and the first term is 1. A subscript 11 is the last term. The last term is 31. Once we have evaluated the expression on the right, yes?
You get, can I say the answer?
Yeah, go ahead.
You get 176.
176. 176 is the sum of every single number in this series. So that's just 11 over 2 times 1 plus 31. Are there any questions about this example? All right. Now we're going to talk about summation notation. This character here, this is the Greek symbol sigma. Capital G. So this is just the Greek symbol for sigma. We use this as an alternate. So this formula, we use this formula to find the sum of a series. We could also use sigma notation to find the sum of a series. What you need to know about summation notation: the number that goes on top is always the number of terms. The number of terms. And we already discussed how we could find the number of terms. The number of terms. The number on bottom is always just going to be n equals 1. That just means we start from the first term. Start from the first term. What we put on top is just the number of terms. And on the right side is just going to be the explicit formula. Explicit formula. So let's take a look at the example we just did. And we'll use summation notation. And we'll get the same answer of, what was it, 196, 170, something like that? 176. So here. Let's take a look at this series here. Difference. Is that what I want to do? Number of terms equal 1. All right. Clear this in. You could forget about this one here. This is the formula. We'll forget about that for now. All right. This is the one, right? 176. All right. This is the same one we just did using the formula. We already determined that how many terms were there? We know n equals 11. So when you write this in summation notation is sigma. The number of terms goes on top. Number of terms goes on top. N equals 1 goes on bottom. And inside the parentheses, we have to put the explicit formula. Explicit formula. What is the explicit formula? We learned about the explicit formula 2 days ago. But just to recap, the explicit formula is a subscript n equals a subscript 1 plus n minus 1 times the common difference. Hopefully you did not forget this. It was just 2 days ago when we were using this here. So to find the explicit formula, what's the first term? 1 plus n minus 1. What's the common difference? 3. We distribute the 3 to get rid of the parentheses. We have 1 plus 3n minus 3. Is everyone on the same page about what's going on here? Combine like terms. After we combine like terms, what do we have? Huh? 3n minus 2. Or negative 2 plus 3n, either one. Let's just write it as negative 2 plus 3n. Does anyone have any questions about how we simplified this here? This is the explicit formula. This is the explicit formula. Negative 2 plus 3n goes in there. That would be writing a series in summation notation. This is summation notation. Can you take your calculator out, please? Hit math 0. Hit math 0. This is summation notation. What should we put on top? 11. So put 11 on top. Use x for n. 11 on top. On the bottom, put x equals 1. And what are we going to put in here? Negative 2 plus 3x. And if we enter, plus 3x, sorry. Plus 3x. My fault. I put minus 3x. Negative 2 plus 3x. And we get 176. The same answer as 176. You could just use that, but you have to know summation notation. Some questions will be given to you just like this. Some questions will be given to you like this. But if it's like this, you could just put this in your calculator, math 0, and summation notation will give you the same 176. All right, so enter this one here. See what you get. What is the sum of the series? This is already in summation notation. What do you get? 125? 125. So if the question is already given to you in summation notation, just type it into your calculator. If it's given to you like this, you have options. You could do it the first way, or you could rewrite this in summation notation. So just so we have more practice, let's just write this in summation notation, and then that's the end of the lesson. In summation notation, we have sigma. What goes on top? How many terms are there? How many terms are there? 8. All right. So 8 goes on top. What goes on bottom? N equals 1 always goes on bottom. What's the explicit formula now? Explicit formula.
1 plus n minus 1, 2.
N minus 1, common difference is 2, but I don't like 1 plus. Where'd you get 1 plus from?
I'm going to say A1.
A subscript 1, what's A subscript 1?
7.
7. So the explicit formula is 7 plus n minus 1 times 2. Now we have to simplify this. How can we simplify this explicit formula? Angelina? 7 what? That wouldn't be it. Antonino?
I got 2n plus 5.
That's it. So this would be 2n minus 2. And then after you combine like terms, it is 5 plus 2n. So 5 plus 2n is the explicit formula. And this is our summation notation here. 8 on top, n equals 1 on bottom, 5 plus 2n is the summation notation.
Does it matter whether you put 5 or 2n?
Doesn't matter, you can do 2n plus 5.
Okay.
Juliet?
Wait, how do you get the 8 on top?
The 8?
Yeah.
The number on top is the number of terms. And you know how to find the number of terms?
Yeah.
All right. Maria G?
Don't you know that n equals 1?
It's always going to be n equals 1. N equals 1 just tells the calculator to start from the first term, which means to start from 7. If you put n equals 2, the calculator is going to start at 9 instead of 7 and give you the sum starting from 9 instead of 7. All right, that's the end of the lesson. You have today 10 minutes and all of tomorrow. I will not be here tomorrow to get this work done. And then Monday, we'll do geometric series. Tuesday, we'll review. I'll introduce the recursive formulas, not much, and we should have our test on Wednesday. Juliet?
It would be on like the bottom, it would be n equals 1 because there's like a first term.
Yes,
First term 7.
that's fine, but n equals 1 just means the first term, not the value of the first term, just the first term itself. Yeah.